This is Environmental Science 2, Chapter 11, Part 2 on Energy. In this portion of the video lecture, we will be discussing nuclear energy, how it works, and pros and cons. Nuclear energy is another one of those alternative sources of energy. It is the energy that is contained within the nucleus. Remember, we have inside the atom the protons and the neutrons are what is in the nucleus. And when those particles are separated, we call that nuclear fission. So this is when subatomic bonds are broken. So nuclear fission is you take one big atom and you break it up into little pieces. And every time you break those big atoms up, we get a very large amount of energy being released from those atomic bonds. Nuclear fission is the main source of nuclear energy because that decay process happens at a very controlled pace, and it releases that energy slowly over a long period of time. So from the subatomic particles ripping apart, the heat that is generated from that process, there's a massive amount of heat generated, which blows steam to drive a turbine to create electricity. So within the reactor core, that's where the radioactive elements are, and as they decay, the heat then from that process boils the water to drive steam, to run the turbine, to generate electricity. Now there are some advantages to using nuclear power. The most common type of nuclear fuel is uranium-235. Over time, uranium-235 will decay into lead, which is non-radioactive. Very small amounts of uranium-235 can release as much energy as 3.5 tons of coal. The supplies of uranium-235 are not infinite, but again, very small amounts of this can replace many, many tons of fossil fuel burning. Nuclear energy does not produce any greenhouse gases whatsoever. The thing that you see coming out of a nuclear power plant, their stacks, that's water vapor. It's not toxic gases, it is just steam. Well-designed nuclear reactors do require a very minimum amount of maintenance. Most of the process is automated. There are a few human aspects of maintaining those machines to make sure that they are running properly. But the overall process of taking the uranium-235 and getting that energy from it is basically automated. Now, of course, there are disadvantages to using nuclear energy, and the main disadvantage is that after uranium-235 is spent, that's what they say when it's all used up, they do have to store that because it is a byproduct and it is toxic. At the present time, there are storage facilities around the United States as well as internationally for other countries that use nuclear power. The main place where the United States stores much of its nuclear waste is, believe it or not, inside the Rocky Mountains in a place called Yucca Mountain. There have been access tunnels that have been dug, and the radioactive waste is sealed very deep within the mountain range. In case of an accident or a leakage, more than likely that would not make its way to either groundwater or surface, the surface to contaminate the area with radioactive waste. We measure how radioactive something is by knowing its half-life. Remember, radioactive substances decay at a constant rate. It's almost like a clock. So we can measure the time that it takes for uranium-235 to degrade into its normal stable counterpart of lead. So we can figure out how radioactive something is by taking the radioactive substance and comparing it to the proportion of normal stable substances in a material. Nuclear power plants are expensive to build. They are very minimum maintenance once they're up and running, but those facilities are very expensive to build. They're also difficult to allow in cities. Many people have a lot of misconceptions and as well as fears of nuclear energy, and they don't want a nuclear power plant right in their backyard. As far as we can tell, the nuclear fuel or uranium-235 stores is in a fairly short supply. Perhaps, estimations of 100 to 200 years of fuel remain. We've learned also that accidents can occur, that downtime can be very costly and possibly deadly. We have learned from mistakes, but again, that doesn't mean that those mistakes or accidents, whether it be human error or machine error, those will happen. And every nuclear power plant has a contingency plan and a plan of action for when things go wrong, but they're never foolproof. So the ways that the radioactive waste can actually affect people and other living organisms, once the groundwater or the surface has been contaminated, a lot of those toxic materials can get into things that we eat or breathe or drink. And so environmental health is one of those new areas of medicine that has gotten a lot of publicity over the last 20 or 30 years, from taking a look at people that have either lived in or around areas of nuclear power plants, testing for rates of different types of cancers and the like, has shown that there can be some lasting effects of having nuclear power plants within the vicinity of residential areas. Chernobyl in Russia in 1986 was a very famous, publicized nuclear power accident. The plant is still, to this day, in 2016, shut down. It has certain areas that are still restricted for people to go in because the radiation levels are still actually too high. 3 Mile Island in Pennsylvania, there was also an accident there with the nuclear reactor number 2. And those efforts to clean up 3 Mile Island, that process is still happening today. 3 Mile Island and areas around Dauphin County, Pennsylvania, do have increased rates of different types of cancers that are associated with the exposure to radiation, still over 30 years later. Nuclear fusion is a technology that is in its infancy, but is trying to be developed. Nuclear fusion is the opposite of fission. So fission is taking a big molecule and breaking it up into little parts, whereas nuclear fusion is taking little parts and putting them together, fusing them together to make a bigger, heavier element. This will also generate energy. This is what happens in our own sun. So this type of nuclear power is in its infancy, mainly because the technology for fusion hasn't been developed for a very wide-scale use. Nuclear fusion in test labs can work. The apparatus that's set up to generate the energy can work, but it's on a very small scale. And there are problems with actually containing the amount of energy that fusion produces. It's not quite as consistent as nuclear fission. But perhaps maybe within your lifetime there will be ways to figure out that technology to work for that wide scale and safe use. This has been Environmental Science 2, Chapter 11, Part 2 on waste.